I'm Won-Lee. I have been explaining about transformation of variable x transformation, variable y transformation. Today, I'm gonna take simple example for transformation of y. Let's see. This is example. Let us apply the following data to a simple linear regression model. They are 7, 7, 7, 21 data, x and y, okay? So we got a result from computer software. Here is x bar, sorry, intercept is minus 2.543, e plus 0.4 means 10 to the power 4, okay, here. So big number, and p-value is what? Here, 0.000. And coefficient of x is 3884.975697. The p-value also 0.000. And the r-square determination coefficient is here, 0.797. So this one, x, explanatory variable x, explains the variability of y 29.7%. What else? We don't know. Anyway, we get a result like this. In the case of applying the linear regression model, there were no unusual points. What is the problem of this result? Okay, enough r square, and the p-value is 0.000000. So you accept, you wanna use this result, but however, I think you must examine residual plot from your result, okay? However, upon examining the residual plot, we can identify issues regarding the assumptions about error. Okay, check the assumption of epsilon. So this is studentized residual, and here what y hat. This is usual residual plot. The scatter plot of x and y. Okay, assumption about residual plot. We got residual plot like this. It is not normal. Okay, how to the shape of this residual plot. This part is all right. Okay, in a band, certain band, but from here, it is not normal residual plot. This is very big band. There is a big wide band of residuals. So you check the scatter plot of x and y, raw data. Then these data, 21 data, show us this kind of plot. What is this? This one is like this, right? Then let's see. This is the problem about transformation of y. It shows like this kind of thing. So log transformation is needed to this data. This indicates a typical case where log transformation of y is needed. Okay, so the model will be used like this: log y plus beta 0 plus beta 1 x plus epsilon, log transformation of y. So you try again to estimate the regression line. This is result. Intercept is 8.2574, p-value 0.000 plus 0.1249, p-value 0.000, and r square is what? 0.902. Previously, there was 0.797. Now, it increased about 10%. And the residual plot for this model is like this, in some band like this. Consistent distribution of residual, we can see. So this one, this residual plot indicates the assumption about epsilon holds. Therefore, we better use this result for your analysis. Although the coefficient of determination has improved significantly, about 10%, and the results are satisfactory. But there is an issue with interpreting the estimated coefficient of 0.1249. How to interpret this result? Increase of 1 unit, increase 1 unit of x, increase this much to log y. But we cannot easily figure it out, the log y. But anyway, this is more accurate result for the relationship between x and y. So in order to prediction, you use this one. For some value of x, for example, say x here, what, 17, there is no 17 here, okay, 17, then what is value of y? Predict the value of y. For you substitute 17 in this equation and you can get a y, okay? Okay, anyway, this is the, I think this is a essential transformation of variable x or y, sometimes x and y, okay? So this is it for transformation of a variable. Thank you. Bye.